Hey everyone, Tim here, Silver Pascal Coder. In today's video we're going to be looking at interfacing Pascal with C libraries. In particular we're using a shared library. In another video we'll look at using static libraries, but we're going to be using Raylib here, and yes, I am aware there is a Raylib for Lazarus package, but for the purposes of this video we're not going to be using that. What we are going to be looking at is this header file here and this demo program here, all of which is in C. So if we jump into our Lazarus environment here, yes, I do have a few links here which we will be looking at. I'll just run this for the moment so you get an idea of what you're looking at, and we can move it around, we can zoom in and out, etc. And then we can hit escape to close it. So in a typical and this is background here, in a typical Raylib type application you initialize a window with init window. With 3D stuff you can set up a camera, and then you're in a loop which basically says while the window should not close, you're going to be doing something. And then at the end of that loop, you close the window, and then while you are in the loop, obviously you begin drawing, end drawing, and something happens in the middle of that. So in the case of a 3D, yes, we are using a structure. So when we are looking at using C libraries in Pascal, then we need to be aware of the names of functions, the calling convention, the types that are used, whether records are used, etc. On that, have a look at this particular page here, which includes information about the C type and the corresponding Pascal type here. So if you see an int in C, then it will become an int, likely to be an integer in Pascal. If you see a char star, it will become a p char in free Pascal. So the first call here then becomes init window, and here we can see that init window is basically the return type here is void. Now a void in C is the same as a procedure in Pascal, whereas if it would, if you can see something like a bool or an int on the left hand side of the function name, it becomes a function. The only exception to that would be if you had like a void pointer, but that's beyond the scope of this video. So here we can see that there are two integers, a width and a height, and then we have a title. So we need to have that particular procedure here, and using the information from here, we got two ints and a char star, so I've got two integers and a p char. Which is what you can see here. The next part is perhaps, I wouldn't say tricky, but every function, I would say, from a cdecl, unless you are told otherwise, will have a C style declaration. Why is that? That is because of the way in which procedures get called, or how the stack is used when calling procedures, and the order in which parameters are pushed onto the stack. And there is a free Pascal resource that will give you information about this. I'll just paste that there, and we'll make that a bit bigger as well. So here you can see that when we are using a C style declaration, then rather than the parameters going from left to right, for instance, the items are put onto the stack from right to left. The stack gets cleaned up by the caller, and then there's an alignment. Compare that to Pascal, for instance, where we go from left to right, and the callee, is responsible for cleaning up the stack. So there's something, they're just a couple of differences. Have a look at this page for more information. And so back over here, and because we are using a shared library, we are now looking at telling it the The name of the shared library we're using. Otherwise, it's also just external. And then we have the name of the corresponding function in the shared library here. Functions then, or procedures, functions or procedures without parameters become very easy. So the opposite, once if you've done it in an init window, somewhere you need to do a close window. Now here, if we look at the Raylib one, close window takes no parameters. Actually, all these, for instance, all of these functions or procedures here do not take any parameters actually. So because I've got the word void here. So in this particular case here, it's closed window. We still say it's a C style C declaration, and the rest of it is the same, except for the fact that the name of the function, is different in Raylib. So that covers, let's say, that function and that function. The next thing we have in our program, though, is now a camera position. Now, a camera, is a structure, and so if we can look for the word C-A-M-E-R. So here now we can see a structure here, and we've got some vector 3s, which are going to be x, y, z parameters essentially, a field of view aperture, and then a projection, and the projection can be perspective or orthographic. So what is a vector 3? Well, let's now search for vector 3. As I said, it's a float, or 3 floats, and you can also see what a vector 2 looks like, and also what a vector 4 looks like. So if we use our table from previously, then we know that and actually I'll bring it up, I'll bring the page up actually. So let's go to here, and a float is a single here, and when we jump back to our code here, what have I got here? You can see that we are using singles here as well. So we can just, then drop them in, as we can see in the Raylib. We then have another float, which is going to be a single, and then an integer, and an integer is going to be an integer here. So far, so good. And then we can, define our type, and then set up these particular variables here, set up these particular attributes, elements of the structure there. Now you'll note here now that then we have these first 3 parameters are vectors, as we said. So we need to be able to create we need to be able to create a vector, to put into that position here. So in order to do that, I have just created a couple of simple functions which will basically allow us to create, a vector 3 based on AX, AY, and AZ. And that basically will return that vector 3 and store that into the position. And we can do the same thing for the other parameters here. Now the next part of it is that we're going to now see that, we now have this camera perspective. What's that? So if we jump over to here and back into here, we can see that, and now you can see that we're using an enum. Now an enum here is going to be, first of all, it's an integer in the record structure. So strictly speaking, this is going to be an integer as well. Now here they're just saying that the initial value, or if it's perspective, is going to be 0, and the next will be +1, +2, +3, and so on. So if we just look at this example here for the end patch layout, then n3 patch horizontal would be equal to 2, and the vertical will be equal to 1. You know, if you look at 0, 1, 0, 1, 2, 3, and 4. So now when we go back to our code now, we can, you know, have that defined there, or use that there, and have it declared up here where we are saying that the perspective camera is 0 and the orthographic is 1 there, and just as a note, camera free is also 1 if you were to look in the source here. Which actually, in this case here, we are looking at bytes here. So when we look at color, actually let's go to the very top. I think we need to do for this one. Here we go, a color, an alpha value. So a color, it consists of 4 unsigned chars. Now we know that an unsigned char now is going to be a byte in Pascal. Having a table like this, by the way, makes your conversion, you know, much simpler. So if you're looking for a resource, keep this one handy. I'm just making it easier for myself. Anyway, so basically we've got, you know, we now have a color defined as well, and now that we've got some colors defined, we can actually create, you know, or define our colors. Now for these particular colors here, you can see them defined here. If you want to, so basically these are, well, define in Pascal basically will replace that value there with all of that there. In Pascal we would make that into a constant. So as a constant now, light grey becomes a color, in which case we've got the red, green, blue, and alpha values set to that. So light grey is a 200, 200, 200, and 255, 200, 200, 200, and 255, which you see then. You can work your way down the list. These last two I've just added in for my own benefit. So we've now got our colors. You know, we do have a couple of colors set up now. Window should close again. We are in the header file. Window should close, as we said before, is a function. It returns a boolean and it doesn't have any parameters. So window should close. It's a boolean. There's no parameters. And we still have the, you know, C declaration, external, and the other parts here. And the name in the shared library is window should close. So now we've done all the preliminary work enable for us to use some C functions to do something in Pascal. Now you'll see here that I've got a camera. That we are using a camera here, and the camera, by the way, is just an instance of that. We're not using a pointer, it is just the record. Now when you look at the update when you look at the update camera function, you can see here that we're actually passing in a pointer to a camera, and we also have a mode here. If you compare this to see that with what you would see here, then you can see here that we have an instance of a camera, which is a record, and in C we're passing across the address of that camera. The equivalent code in Pascal will look like this, where we're going to pass the address of the camera, perhaps in the simplest way you can see it, and camera free, as I've mentioned about that one before. This next function here, you can see Begin drawing. Begin drawing again is a procedure. It doesn't have any parameters, so it will just become a it looks exactly like the other function we had previously, which is a C declaration that isn't parameters, has an and is a function, because it was a void type in the C header file. Now perhaps one of the more interesting functions then, becomes, well, when we want to draw a cube or we want to draw some cube wires. So let's look at, let's find the draw cube function here. And so we go back into here, and you can see that we are passing across a vector 3, and then we have a width, a height, a length, and a color. For the wires, we also have a vector 3, 3 floats, and a color. So we have a vector here, 3 floats, and a color. So a float again is a single value. So we're going to so those floats now become singles. The first parameter, being a vector 3, will become a let's go back here, will become a vector 3 here, and the last parameter then was a color, as we said. So basically, once you've got the once you have converted the functions and the procedures in the header file into your own unit, you can then build it. And obviously now when we build it, we are going to have a dependency on the Raylib. If you've done all of that, hang, let's just see what I've, just to make sure I haven't messed up anything here. We can now, once you've converted, you can then build your program, and then fingers crossed, we've converted it, it builds correctly. Doesn't mean it works, it just means it's built. And then you can actually, run it, and we can see what the program does. So here now you can see that we have successfully been able to use convert something that was used in C, and we can use it now in Pascal by defining the interface to the C library. So I think what we might do now for the last part of this video is we're going to just add in this last line here, so which is just after we update the camera. So let's just copy that line into our Delphi program here. Let's go back here, and we need to then, so basically here what we're going to do is going to be 3 zeros, so we can actually copy that to here, make that into an assignment. Now we have not changed, or we have not added this particular function in here, so let's see whether we can find what that looks like over here. So basically what we've got here is a function, and we're now going to put that over here. It's a boolean. From there, its name is that. We have an integer. Now we'll go back to here. An integer here is going to be a Pascal integer. So let's just do okay, so what do we got here? It is definitely an integer being used there, so looks like I need to go for odd. Let's try it this way, odd that way. And it's not running, so now let's run it, shall we? and over to, let's say we're now over, okay, let's hit the Z key and it now gets centered. So we're off the screen that we don't like, we hit Z and now we're back there. So basically what we're looking at here is we were able to now just add in that function call to is key pressed to recenter the camera where we're looking. So, and that didn't take very long. Obviously we had the header file, you know, for the C, which makes it a lot easier. You know, we can just, you know, flip things around a bit. The calling, because, you know, Pascal thought this was essentially would have been a char here, and it was looking for an integer, so we've had to use ORD here to, you know, handle that. So I guess the one thing I'm suggesting here is to, it can seem daunting when you are wanting to use C functions in your Pascal programs, but perhaps the one thing you could try is to just build your own, just try something that's been done before and see whether you can convert a couple of routines and call them. The next step might be to write your own C library and try and call it, or the next function might be you have a C library that you want to use but hasn't been converted into Pascal yet. So I guess what I'm trying to say is don't be afraid, because the worst that'll happen is that it won't run, and in which case there are forums on which you can get help. So, and on that note, I hope you got something out of this video. Don't forget to like and subscribe, and until next time, happy coding, and I'll see you then. Bye.